So far we have looked into electrical charges, the electrical current, that is flow of charge, and voltage, that is electrical potential due to the placement of charges, or the energy required to generate motion in charges. Now we will look into power and energy in electrical system. Energy is something we are charged for by electrical supplies. Energy is the ability to do work, and power is the rate at which energy is used or produced. Watt is the unit of electrical power. 1 watt is the amount of power when 1 joule of energy is used in 1 second. Bigger units of power are expressed in kilowatts, megawatts, even gigawatts. Power, it is the time rate at which energy is absorbed or delivered. It is measured in watt. Mathematically, we can write power is time rate of change of energy. Applying chain rule of derivative, we can write this derivative as change of energy with respect to change in charge multiplied by time rate of change of charge. Now, change of energy with respect to change of charge is given as voltage, and rate of change of charge is given as current. So we can say power is product of voltage and current, and the units are obviously watts. Now, in any electrical system, we can calculate the power delivered or absorbed by that electrical system by multiplying voltage across that system or voltage across that electrical element and current going through that electrical system or current through that element. Passive sign convention. If the current arrow is directed into the positive terminal of an electrical element, then power, which is obviously product of voltage and current, yields absorbed power. It means that power is absorbed by the electrical element. But if the result of the product of voltage and current is negative, then it means our assumption that power is absorbed by the element is wrong. In fact, power is being generated by the element. If the current arrow is directed out of the positive terminal of the circuit element, then the product voltage into current, which gives power, means that power is supplied by the electrical element. But if the result of the multiplication of voltage and current or the product of voltage and current is negative, it means our assumption is wrong. The power now here is being absorbed by the element. So passive sign convention tells us about whether the power is generated by the element or is absorbed by the element. So far we have studied the power, the nature of power, electrical power, which is product of voltage and current. Now we can solve a small problem. In this given problem, we have to find power being delivered at the circuit at time 5 milliseconds. So at instant when the time is 5 milliseconds, at that instant we have to calculate power. So it will be instantaneous power. Why it will be instantaneous power? Because the voltage across the given element is function of time. So we have instantaneous voltage, while the current is constant. So we have choice of 4 answers. So if our calculation matches one of the answer, so that will be our answer. At this point, I will take a pause so you can do your calculation. Then I will reveal the correct answer. Now, this is the answer to the given problem. Since we want to find out instantaneous power, so power is function of time. Current is constant quantity, so it is represented by capital I, while voltage is instantaneous, so it is represented by a small v. Now, since it's a function of time, so we have t in the bracket. So if we multiply these two quantities, 3.2 into 8 e raised to power minus 100t. So we replace t by the time value, which is 5 milliseconds. So 5 milliseconds is 5 into 10 to the power minus 3. If we multiply these two quantities, we get the result 15.53 watt. So our answer to the given problem is B, which is 15.53 watt. So this concludes our study, or rather brief study, of electrical power.